Today I'm going to be doing a review on trigonometry with right-angled triangles. It's important that we start off by looking at how we actually label the triangles. This is the starting point and the part that you need to get correct in order to be able to know which rule that we're going to use. So with the two triangles that I have in front of us, we've got our symbol theta over here and over here. Now we just use the sign theta, it's just a Greek letter, to identify the unknown angle. We use this theta to help us identify which sides are which. Now the one that we should already know is the hypotenuse. The hypotenuse is opposite our right angle. So hopefully we can identify that one without even knowing anything about trigonometry. With the other two sides, which are the two shorter sides, because the hypotenuse is always the longest side of your triangle, we can then go using the theta to identify that this line over here, line BC, will be the opposite side because it's opposite theta. Then the last line that we have not labelled is the one that's next to the theta. And another word that we use is the word adjacent. That's adjacent to theta. So looking at our second triangle, because theta has changed positions, that means we change the naming of our sides. So that's why you need to be very mindful of where your opposite and your adjacent side will be in order to label our triangles. Moving on to our next slide, we now can have a look at the acronym that we use, which is SOHCAHTOA. We use this to help us identify the three rules that we can pick. So we've got sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta, which is equal to opposite over adjacent. Please remember, before you do any calculations on your calculator, it needs to be in degrees mode. Otherwise, you may end up with some wrong answers when you do your calculations. So let's actually apply some of these rules to some questions. Here we have two triangles. We've been asked to find the side lengths of these triangles. All right. Typically we ask you to go to 2 decimal places. So just be mindful of what the question might be asking you to do and how many decimal places you need to go. The first thing I will do is I'll actually label my triangle. So this is my hypotenuse, this is my opposite, and this is my adjacent. Notice the 70 degrees is my angle. It's not theta because they've told us what the angle size is. Once I've actually labelled my sides, look at the sides of the triangle that have information. So your opposite and your adjacent has information. We have a side length of 5 and we have y, which we're trying to find. There is nothing on my hypotenuse. So when you look at your rule, SOHCAHTOA, this can help you pick which rule you're going to use. Anything with the h in it for the hypotenuse will be unuseful to you. So that leaves me with tan theta is equal to opposite over adjacent. Like any rule, I'm now just going to replace my letters with the information I have in the diagram. My theta is 70, so it becomes tan 70 is equal to y over 5. Working out is really important, so please make sure you show all steps. Now our goal is to get y on its own, At the moment, y is being divided by 5. The opposite of dividing is timesing. So it moves the timesing of 5 goes to the other side of my equals, and this allows y to be on its own. I complete the calculation and I get 13.73738. Now rounding it to 2 decimal places, that's going to be 13.74. There are no units, so I'm just going to write units equals y. And that is my final answer. Now in a test situation, what would I be looking for? I'd be looking for some working out. This would typically be a 2-mark question. So show me something. In case you have not got your calculator on degrees mode and you get the wrong answer, I'm at least able to give you the working out mark because you've done the working correctly. Moving on to our second triangle, once again I start the process by labelling my triangle, my hypotenuse, my opposite and my adjacent. Same thing as last time. So, ka, toa. I'm going to cancel out which one does not have h in it because I have no information on my hypotenuse side, and once again I'm left with tan. Tan theta is equal to opposite over adjacent. I fill in the information. To replace the letters I can. My opposite is 5.55 and my adjacent side is now my x. Notice how the two questions are different in the fact that now the x is doing the dividing in my second triangle. Now this is important to understand which one is doing the dividing. Because the letter's doing the dividing, you actually need to move that to go to the other side, and it's going to become multiplication. So it's going to be tan 45 times x is equal to 5.55. And once again, we want to get x on its own. So now that that's multiplication, it's going to be x is equal to 5.55 divided by tan 45. Now I've shown you probably the longer way of how to do it, just so that you get an understanding of what I'm doing. But what you should see is that if you've got the letter at the bottom, which is doing the dividing, you can simply swap tan 45 with the x to make the process a little bit quicker when you're in a test situation. Once I've done the calculation, my answers actually come out as 5.55. There aren't any units for this. But if there were, make sure you write centimetres or metres or whatever the unit is going to be in. Now, as you can see, this means this triangle has the two shorter sides being the same length. Same as the first triangle. You get 1 mark for showing me some working out and then 1 mark for the answer. Moving on to our next question, we're looking at now finding the angles. Now, in order to find the angles using trigonometry, you need to have 2 side lengths in order to work it. The process at the start is still the same. So we have our hypotenuse, our opposite, and my adjacent. So you label your sides accordingly. You're still picking from so, ka, toa. You can't use anything that has an h in it because we don't have the side length for h, and we need 2 side lengths in order to find theta. So 2 side lengths, we've got A and O, so that leaves me with tan. Tan theta is equal to opposite over adjacent. Tan theta is equal to 5 over 5. Now we all know that 5 over 5 would be 1, but I would recommend just leaving it as a fraction, especially if it is a recurring decimal. It's more accurate to leave it as a fraction. Now we are in this position where we need to get theta on its own. Theta is like having an x or a y. We want it to be on its own. Tan being a ratio number, there's an opposite for tan. Like there's an opposite for multiply and divide, there is an opposite for tan. Theta is equal to tan minus 1. This is on your calculator. If you're using a scientific calculator, most scientific calculators, you would push second function tan. Bracket 5 divided by 5. Therefore, theta is equal to 45 degrees. Notice we're finding the angle, so the unit we use is degrees. Moving on to our second triangle. Label it H, O, A, So, Ka, Toa. I now have nothing on my A. I can't use anything that has an A in it. So cos and tan are out, and I'm left with sine. Sine theta is equal to opposite over hypotenuse. I don't know what theta is. My opposite is 1.5 over 2. Same as tan, sine has an opposite. And you guessed it, it's sine minus 1. Second function, sine on your calculator, bracket 1.5 divided by 2, which leaves us with theta equaling 48.5904. But if I was to round this to the nearest degree, it would be 49 degrees. Let's have a look at a worded problem. A ladder reaches 5.5 metres up a wall and sits 2 metres from the base of the wall. Find the angle the ladder makes with the horizontal correct to 2 decimal places. Step 1 when doing a worded problem is to ensure that you read the question first, then underline the important bits of information so that you can pop it onto a diagram. Now there is a diagram there for you to give you an idea of how to start this process. As you can see, what we're actually creating is we're creating that right angle triangle that we need. And that's where our right angle sits there. And they're asking us to find the angle that the ladder makes with the horizontal, which is the ground. They told us the ladder reaches 5.5 metres up the wall. So the ladder reaches 5.5 metres up that wall. It sits 2 metres from the base of the ladder. So it sits 2 metres from the base of the ladder. Once you've got that information onto a diagram, hopefully it makes that process that much easier to find out what theta is. They also want us to make sure that it's going to 2 decimal places. So that's my hypotenuse, that's my opposite, and that's my adjacent. I don't want anything with the H in it. So, ka, toa, so I can't use sine and I can't use cos. So I'm going to use tan theta is equal to opposite over adjacent. I'm trying to find theta, so that stays as is. My opposite is 5.5 and my adjacent is 2. theta is equal to tan minus 1, 5.5 divided by 2. Therefore, theta is equal to 70.02 as I round it to 2 decimal places as requested. Moving on to a couple of more worded problems, we can start using some language like angles of elevation and angles of depression. Starting off with angles of elevation, here is a problem where we actually use that language in the question, which helps you set up your diagram. The altitude of an aeroplane is 500 metres and the angle of elevation from the runway to the aeroplane is 15 degrees. Find the horizontal distance from the aeroplane to the runway to the nearest centimetre. Now, I'm not an extremely good drawer, so I'm going to do the best that I can with this. So we have an aeroplane that is in the air over here, and it is above the air at 500 metres. That's the altitude. With the altitude, they've also told us that it creates an angle of elevation. Now, when we talk about the angle of elevation, it's this little angle here, which is created at the horizontal and looking up at whatever object is in the sky. So that's where your 15 degrees of angle of elevation will be. They're asking us to find the horizontal distance from the aeroplane to the runway. So let's say we have our runway here that the aeroplane is trying to land on. So that's why they want to find out this horizontal distance given the information we've got. Once you've got a diagram, now label it. So this is your hypotenuse, this is your opposite, and this is your adjacent. Same as all the other times, I can't use anything that has the hypotenuse in it. So therefore I'm using tan. Tan theta is equal to opposite over adjacent. My theta is 15 degrees, my opposite is 500, and my adjacent is the x. This is that scenario where x is doing the dividing, so remember, we need to swap those two around. And that allows x to be on its own. So it's 500 divided by tan 15. And that leaves x to equal 1866.03, and we were in metres, and notice they want it to the nearest centimetre. So if I'm already in the units of metres, that means it's 2 decimal places. Some people like to change the units to be in centimetres from the word go, therefore your answer might be slightly different just because you've converted it to centimetres. Now looking at the angles of depression. So when we're looking at the angles of depression, this is where we talk about the object from above and the angle of depression that it creates. So find the angle of depression from a lighthouse beacon that is 112 metres above sea level to a boat that is at a horizontal distance of 1.5 kilometres from the lighthouse. Round your answer to the nearest 0.1 of a degree. So let's start with our diagram. So we have our lighthouse, and we're talking about how it's staying at the top of our lighthouse. I really do apologise for my drawing. And there is a boat down here. And look, I've created a right angle triangle. So with this, we've got 1.5 kilometres, which is my horizontal, and the lighthouse, which is 112 metres above sea level. So noticing that you've got 2 units already that are not in the same unit, so we will need to deal with that in a moment. And the other thing is we're now talking about the angle of depression. So it's talking about this angle here, which is actually outside of our triangle, but that is where the angle of depression sits. So they're asking us to find this angle here, which means we need to think about how we may do this. And this is where the topic of parallel lines can help us out, because if we know this angle where we're trying to find theta will be the same size as this angle here because of alternate angles. So this angle here, we can also label it theta. They will be exactly the same size. Now there is 1,000 metres in a kilometre, so I'm going to change the kilometres to be into metres. So this is going to be 1,500 metres. Now that we're all in the same units, we can go and label our triangle. So because we're talking about the theta inside of my triangle, I'm going to use that to help me label it. This is my hypotenuse, this is my opposite, and this is my adjacent. I can't use anything with a h in it, which leaves me with tan theta is equal to opposite over adjacent. I am trying to find out what theta is. My opposite is 112 metres and my adjacent is 1,500 metres. So tan minus 1 bracket 112 divided by 1,500, and then want the answer to the 0.1 of a degree, so this will be 4.3 degrees when rounding correctly. And that is my angle of depression. I hope this has been a good recap of using trigonometry with right angle triangles. If you have any questions, feel free to ask, and good luck.